Okay, we're back. We finished the first 28 problems. Now we're in the 29th problem, and we'll move forward. It's a long section. That's why I broke it into two parts. So let's do 29. And 29 wants me to take this fraction, which has a root in the denominator. We have to get rid of the root in the denominator. We need to make it rational. So let me write this down for you. It's 5, the cube root of 3a squared. And we need to make the bottom we need to turn 3 into a perfect cube. And the way to do that is to multiply it by the cube root of 9, because 9 times 3 is 27. And that would be a perfect cube. Now a squared to make it a perfect cube would be just an a. So what do you get there? Well, let's write that down for you. You get 5 cube root of 9a. And on bottom, what do you get? You get the cube root. 3 times 9 is 27, and a squared times a is a cubed. All right, let's write that down now. So it's 5 cube root of 9a, and on bottom you get 3a. All right, this is the answer that's listed right over here. All right, this one over here, again, they want to rationalize the denominator. The way to do that is to multiply it by its conjugate. 5 minus root 2, and this is 5 plus root 2. So I can multiply the bottom by its conjugate, which is 5 minus root 2. And I multiply the top by 5 minus root 2. I'm just simply building a fraction. And what do you get here? I'll write down the steps for you. 5 times 5 is 25. Then you're going to get, minus 5 root 2, plus 5 root 2. And then you're going to get minus 2. On top, what do you get? You get 25 minus 5 root 2, minus 5 root 2. And then you're going to get, let's see, minus times minus a positive, plus 2. So what do you get here on top? You get 25 and 2 is 27. And then you get minus 10 root 2's. On bottom, the two middle terms disappear, and you get 23. All right, let's go to the next one. Next one's much more difficult. And why is that? It's got a lot of things going on there, doesn't it? So let me write this down for you. Again, rationalize the denominator. So 3 root a minus 2 root a minus b. On the bottom, you're getting 2 root a minus 3 root a minus b. And again, the trick here is to multiply the denominator by its conjugate. And of course, if you multiply the bottom by the conjugate, you have to multiply the top by the same conjugate. So let's see, that's root 2a. I'm sorry, 2 times root of a plus 3 root a minus b. And the top is going to be 2 root a plus 3 root a minus b. Well, I got to be honest with you. I don't want to go through all the steps and multiply the bottom out. It's fairly simple. What are you going to get? You can get 4a. And then you're going to get minus 9. The two middle terms disappear. That's why I'm not writing them down. And you get a minus b over here. I'll do that later. On the top, a little more complicated. And I'm going to kind of go through it in stages for you. And, 3 root a times 2 root a is 6a. And I'm going to do the end parts, and that's going to be minus 6, a minus b. And the middle guys are the tough guys, right? So what's going to be? It's going to be, let's see, 3 times 3 is 9. And then you're going to get root. Let's see, you would get a squared minus ab. And then what do you get? You would get minus 4 root a squared minus ab. And let me see if I can do that. What do you mean by I do the top and the bottom. And the bottom looks pretty simple to do. It's 4a minus 9a, which is minus 5a. And you get 9b. And what do you get on top? Well, 6a minus 6a, that's gone. And you get 6b now. And then what do you get? You get 5 of those things, those five the root things. 5 of that a squared minus ab, the root of. All right, look at your key. And we're doing okay. All right. This one, again, far more difficult. All right. And someone says, why is it more difficult? They're starting to pile things on now. And let me go through it in stages for you. So 4 minus root 3 minus root 7. And on bottom you get 4 plus root 3 minus root 7. And again, I want to go through it in stages with you. All right? So I'm going to say, 4 plus root 3 plus root 7, 4 plus root 3 plus root 7. And yes, I know it's difficult. I want to carry this out for you, though. And someone says, what are you doing over here? I'm doing this. I'm going to write this down for you. And again, you're going to get quicker over time. I'm not suggesting otherwise, but speed is not of the essence here. Being able to do this is what we're looking forward to. So what are you going to get? You're going to get 4 plus root 3 squared. I'll do that later. And then what are you going to get? The middle terms are going to disappear, and you're going to get minus 7. I definitely want to carry that out. I'm going to do the top two. I'm going to do this over here. All right? That's interesting, right? Let's write that down. I'm going to get 16. These are also conjugates. Depending on how I group them, become conjugates. 16 minus, and we'll simplify this later, root 3 plus root 7 squared. Now, I got to get busy with this. And this is, sort of like if you look at it, I got to do this. And my top is not, I'm not too concerned about the top. It's really the bottom I'm really concerned about. And I want to do the bottom. Now, what do you get there? Let me just write this over. You get 16 plus 3 plus 8 root 3 minus 7. Let me add it all together. And 19 minus 7 is 12 plus 8 root 3s. And what do you get on top? 16 minus, you know what? Maybe I will carry that out. Let me just erase this business over here. Get my pen out again. It'll look like a 14 now, but it's parentheses. And I'm going to do that. I'm going to do, the root 3 plus root 7 squared. That's 3 plus 7. And then what are you going to get? You're going to get 2 root 21s. And mistakes happen. We know that. And let me get this eraser out too. I'm going to really do the whole thing. So what'd you get? 16. Maybe I should write that down. 16 minus, 3 plus 7 is 10, right? Minus 2 root 21s. So what does it give you? 6 minus 2 root 21. And just to simplify it, I'm going to divide everything by 2, right? So what do you get? You would get 3 minus root 21. And on the bottom you get 6 plus 4 root 3. All right, we're almost there. It's going to be 6 minus 4 root 3, 6 minus 4 root 3. The bottom should be fairly easy to do. That's 36. The two middle terms are going to disappear, and we can get minus 16 times 3, which is minus 48. All right, the top, a little more complicated. Let's do it. It's 3 times 6 is 18. And then you're going to get, minus 12 root 3s. And then you get minus 6 root 21s. And then what do you get? You get plus, 4. And 3 times 21 is 63. All right, again, I got to clean it up. And 36 minus 48, that's going to be minus 12. And let me see if I can do the top. That's 18 minus 12, root 3, minus 6, root 21. And then the 63 has a 9 in it. And the square root of 9 is 3, so it'd be plus 12. And that would be 7, root 7. I'm seeing that they're divisible by, each number appears to be divisible by 6, but I'm going to divide everything by minus 6, right? So on the bottom you'd get 2 minus 3 plus 2 root 3s plus root 21 minus 2 root 7s. Now, it's a tough problem. I'm not saying it's not. And I want to kind of look at the answer, and I want to see if we've got it. All right, so I got the 2 on the bottom. I have the minus 3, 2 root 3s, plus root 21, minus 2 root 7s. So I'm feeling pretty good about it. But it's a lot of work. Now, someone says I have a quicker way of doing it. We're not opposed to you doing quick work. We're really not. Like you might say, I see this, I see that. I'm just saying get to the end of it, and this is the end of it. All right. Now, this is more difficult. I'll tell you why. It's not even taught anymore, believe it or not, at the school I teach at. Although we cover, the conjugates for the cubics, we never even mention its use. And this really brings me back to a time when I was teaching at Rutgers University, their flagship campus, which was in New Brunswick, New Jersey. And I remember one of the teachers there, we had a meeting, and one of the teachers had an epiphany. He said, and he announced it to the whole group, he says, now I know why we teach the sum and difference of perfect cubes, so we know they're conjugates, so we can rationalize a fraction that has a cubic in it, in the denominator. But anyway, what would I do over here? And again, I want to point out to you, you have to know this. Right? You got to know that part, all right? And why is that? We're trying to cube those things, right? So I'm looking at it, and I'm trying to figure out, I'll write it down for you. So, and then I'll talk about the work. So 2 is really the cube root of 8. Right, so let me erase that. I knew that much. So I'm going to say this 2 plus the cube root of 3 is really the cube root of 8 plus the cube root of 3. Well, let me get my eraser out. Erase this business over here. Now, if I want to rationalize that, right, what do I have to do? I have to multiply by, I'm looking at this thing over here, right, that thing I just outlined for you. And I got to multiply by something because I had to cube those things, right? So I'm going to multiply by, well, let's write this down. So if you want to rationalize that, you would need to multiply by what? Well, the cube root of 8 squared, which is 64. Middle guy's a tough guy though, right? So what's going to be? It's minus the AB now. I want to point out this is the A, and this is the B. So that would be, let's see, minus the cube root of 24 plus, now I take that B term and square it, and that would be the cube root of 3 squared, which is 9. That's its conjugate, all right? So I want to point out the conjugate of this is this. All right, that's why I wrote that down over there. Remember, if you multiply the bottom, you multiply the top by the same thing. So that's all I did. The bottom turns out to be pretty nice, but if you want to do the law of multiplication, you can. It really just turns out you're cubing those things, which would give you 8 plus 3, which is 11, and you get something pretty nice. All right, a little more difficult. All right, it's 4th powers, and you could do this in stages, or you could think about what its conjugate is. Now, remember I talked about that Rutgers story. You had really found it profoundly impacting if someone said, oh, there's a conjugate to 4th powers, or 4th roots, I mean. And you find it really kind of outrageous, but it's right over here. But I want to point out this could be done in stages. All right? So someone says, what do you mean stages? You could look at it and, basically you could do something like this. In other words, if you didn't see this, which would give you this. In other words, it's conjugate. You probably could do something like this, right? So 4th root of 7 plus the 4th root of 5, 4th root of 7 plus the 4th root of 5. Let's write that down for you. And what would you get over there? Well, let's see. On the top, it's pretty simple, right? You get the 4th root of 7 plus the 4th root of 5. And on the bottom, you would get the 4th root of, well, 7 times 7 is 49, right? And then you get those two middle terms would disappear, and you would get minus the 4th root of, well, 5 times 5 is 25. Right? You could repeat again, and what I mean by that. I'll write that down for you. Kind of crazy look. I'm going to write it down for you. The 4th root of 49 minus the 4th root of 25. Put that on top. And let me do the bottom for you, and I'll tell you what I'm going to get. Just in the bottom. You get the 4th root. Well, 49 is 7 squared, and 7 squared times 7 squared is 7 to the 4th power. Minus 5, 25 is 5 squared, so you can get the 4th root of 5 to the 4th power. Now, what's nice about that? That's rationalized now. And what I mean by that is just simply 7 minus 5, which is going to be 2. All right, let's go over here. I want to point out that's right over here. Again, it's a different way of doing it. I'm not saying it's the same way that it's done over here. I got to do the top now, but I got to be honest with you. I don't know if I want to do the top. And someone says, well, could you do the top? Yeah, I could. And what's top going to be? It's the product of those two over there. And let me write that down. All right, I want to see if I match it up, all right? So what am I doing? And it's my little chicken scratching aside here. The 4th root is 7. Plus the 4th root of 5 times the 4th root of 49 minus the 4th root of 25. I'm going to say it's multiplication. 7 times 49, that's going to be what? 350 minus 3, 343. And then you're going to get, 7 times 25, and that's going to be 175, right? So that's minus the 4th root of 175. And then you're going to get plus the 4th root, and 5 times 49, that's going to be what? 245, right? Yeah, 245. And then you're going to get minus the 4th root, 5 times 25 is 125. All right? So what do you get over there? Well, on top you'd get, I got to make my bigger fraction bar over here, right? Let me erase this over here. I'm going to put it down to the left of it. So I get 2. Let's take a look at this. And the biggest one looks like the 4th root of 343. And then I'm going to put down, looks like 245 is the next one, right? 4th root. We'll check the key later. I'm just looking at these guys over here, my little scratch work on the side. And then I got the 4th root of, I think there might be a mistake on my answer key over here somewhere. Oh, I'm sorry. I made a mistake over here. This is plus plus. Sorry about that. I just noticed it. All right, just noticed it. And that's important. I noticed those things. All right, so I made a correction. Please make note of that. So plus the 4th root of 175 plus the 4th root of 125. All right, and we're getting the same answer. There's no error in the work over here. And I'm glad I had work, by the way, because if I didn't, I wouldn't have noticed that error. I just wouldn't have noticed it. And certainly I should have noticed it because I didn't write the conjugate down. But I did the right multiplication, all right? And I really did the right multiplication. Let me, I guess I should put this over here too. So 4th root, sorry about that. Just to make it complete, 343 plus the 4th root, 245, plus the 4th root of 175, plus the 4th root of 125. Again, these problems are no longer given to algebra students. They're deemed too difficult, all right? Anyway, this one over here, it's a nightmare. All right, so I'm looking at it, and someone's going to say, what could you do about this one over here? I really have to get the same index, and I'm not going to say, I'm definitely not going to get a cube root out of this guy's over here. So I'm looking at this guy. I'll put this is actually a 2. And what's the LCM between 3 and 2 is a 6. So I would need to write this down. Let me write this down for you. The cube root of 2, but I need to make it this 6th root of 2 to some power. I'll just put an n over here. Let me write that down for you. 2 to the 1/3 is going to be 2 to the n over 6. What's 6? 6 is what's n? It's got to be 2. So it's going to be the cube root of 2 is the same thing as the 6th root of 4. All right? And that's important. It's actually, 6th root of 4. All right, let me get my eraser out. This is done. There's no scratch work on the side. I'm looking at the square root of 5 now. And I'll write that down for you. The square root of 5. And I want to make it the 6th root of 5 raised to some power n. So let's write this down. 5 to the 1/2 is going to be equal to 5 to n over 6. I hope you realize the n now has to be 3. So the square root of 5 is the same thing as the 6th root of 5 cubed, which is 125. All right? So this thing over here, it's a lot of work. I'm not saying it's not. Is going to be the 6th root of 4 minus the 6th root of 125. Well, again, you don't have to take this approach they're telling you to take. Let me erase this business over here. What they're looking at is conjugates, though, and there's nothing wrong with that. It's the conjugate. What you can decide to do is, basically, in pieces. All right, what do I mean by that? You could look at this thing as being, let me write this down for you. You know what? I'm going to write the numbers in a little different way. I'm going to write them as, I'll put this over here for you. The 4 I'm going to write as 2 squared. And the 125 I'll write down as 5 cubed. So again, if you decide against this, which is fine by me, you could do this. You could say, the 6th root of 2 squared minus the 6th root of 5 cubed. You could do that. All right? And then what do you get on top? The 6th root of 2 squared minus the 6th root of 5 cubed. And let's just do that. Right? I don't want to do the whole thing for you. You would get the 6th root. Oh, I did the same thing twice. It's an addition problem. I'm sorry about that. I did that before too, and I carried it out. It was kind of crazy, but I did it. So that'd be 6th root of 2 to the 4th minus the 6th root. These are conjugates, by the way. Of, let's see, that would be 5 to the 6th power, right? That was easy, because 5 to the 6th power, the 6th root of that would just be a 5. All right? And then you could just play this game over and over again. And what's the top over here? It's a 6th root. 2 squared minus the 6th, I'm sorry, plus. I keep doing that, don't I? sixth root of 5 cubed. And the bottom, you could just play the trick again and again and again. I got to be honest with you, it takes time to get through that. I'm hoping when you do that, though, including you doing what I'm doing over here, you'll eventually get to the end of it. And it's nightmarish, no doubt about it. All right? Same thing over here, rationalize the denominator. Again, I want to point out what I'm doing over here is what I did in the past. And I look at it. Let me just see what I did there and just make sure. You know what I did? I did some strange things over here, I'll be honest with you. And I look at myself. But again, if I were doing this one over here, let me just take a different approach to it. And what I mean by that, if I looked at this one over here, I'd write them both in the terms of fourth powers, all right? So, like, for example, the square root of 2, and you could do this, nothing wrong with it, could be written as the fourth power of 2 to the n. Let me just, what I mean by that, 2 to the 1/2 is equal 2 to the n over 4. Well, I hope you know n is 2 then, right? So the square root of 2 is the same thing as the fourth root of 2 to the 2 squared, which would be 4, all right? So you could do that too, all right? So let me just erase that, this business up here. I'm going to write that down for you. Root 2 minus the fourth root. Oh, you know what? I'm going to write this one as that same thing. I'm sorry about that. So I'd write it as the fourth root of 4 minus the fourth root of 3. And on bottom, you're going to get the fourth root of 4 minus the fourth root of 3. I'm sorry, plus. I keep doing that. What am I going to do now? Look, multiply the bottom by its conjugate. 4, the simplest one possible, by the way. 4 minus 4 root 3. Do the top. And let's see the bottom. What do you get? You get the fourth root. 4 times 4 is 16, right? And then what do you get? You would get minus the fourth root of 9. I'm going to do the top for you. That would be the fourth root of 16. And then you're going to get minus the fourth root of 12. But you get that twice. So it's minus 2 fourth root of 12. And then last but not least, you get plus the fourth root of 9. All right? Now, I want to point out, the fourth root of 16 is pretty simple. And I'm going to write that down for you now. So I'm going to get my eraser. The fourth root of 16 is 2. Because 2 times 2 is 4, times 2 is 8, times 2 is 16. So the fourth root of 16 is just a 2. Again, don't be discouraged by the amount of work you have to do. So the bottom is 2 minus the fourth root of 9. The top is the fourth root of 16, which is 2, minus 2 fourth root of 12 plus the fourth root of 9. Let's multiply the conjugate. The bottom is going to be 2 minus the fourth root of 9. I'm sorry, plus. I do that. Several times I've done it already, haven't I? My main interest is doing the bottom. 2 times 2 is 4. The middle terms will disappear. And what do you get? Minus the fourth root of 81. Now, certainly, I'm not opposed to doing the top at this point, but the bottom is really nice. And why is that? The fourth root of 81 is just 3. Because 3 times 3 is 9, times 3 is 27, times 3 is 81. So the fourth root of 81 is just the number 3. So I'm going to erase this over here, say it's 3. And 4 minus 3 is just 1. Let me get my eraser out. It's just the top now. So all I got to do is multiply the top out. let's go to town. All right, I hate to do it to you, but I'm going to do it. 2 times 2 is 4. And then you got to get 2, 4th root of 9. So I just completed that. 2 times 2 is 4. 2 times the 4th root of 9 is 2 times 4th root of 9. Then I'm going to get minus 4, 4th root of 12. I'm doing this now. And then you're going to get minus 2, 4th root of, well, 9 times 12 is 90 and 18, 108. It's work, isn't it? Now I'm going to do this, and what's it going to give me? It's going to give me 2, 4th root of 9. And last but not least, what do you get? The 4th root of 81. Well, we just did that before. That's just going to be 3. Well, I got to add all this together now. By the way, it's all over 1. Well, 4 plus 3 is 7. And let's take a look. And I'm going to get 2 and 2. That's going to be 4, 4th root of 9. And then what do I get? I get minus 4, the 4th root of 12. And then I get minus 2. Let me get my eraser here. I don't lose track of anything. Minus 2, 4th root of 108. Now, by the way, I don't mind the answer. I like it. But I want to point out there's something wrong with it. And I'm looking at that. I realize that the 4th root of 9, I'll write this on the side for you, is really the 4th root of a perfect square. So what's that really going to be? It's going to be 3 to the 2/4, which is 3 to the 1/2. So I'm going to write this down. 7 plus 4 square root of 3. Now the 4th root of 12 has no perfect, well, it has a 4 in it, but it's not a perfect square. So 4 times 3 is not going to help me out. And 108, although it contains perfect squares, it doesn't have a perfect square in it. When I say that 108 is not a perfect square. So I'll write this rest down, and then we'll check the key. Again, I did a little differently in the notes. I realize that. This is the answer. Are we getting that? And I'm just checking it. Yeah, we did a great job. All right, let's do the next one, which is 13 minus the root 160. I think what they want to do is find the square root of it. And I always find this to be an interesting problem. And this is another thing that modern-day students would not be able to do, all right? So they want the square root of 13. By the way, that restricts a large number of problems that they can do. Because a lot of problems later on, you have to get them in the form A plus BI. Let's not worry about that so much. But I'm going to make an assumption about this. Now, before I do that, what I want to do, I want to clean it up a little tiny bit. Whoops, that's not cleaning up anything. I'm going to say it's 13, and the 160 is too big for me. So I'm going to say it's 16. So 160 is actually 16 times 10. And the square root is, I'll do this over here. The square root of 16 is 4 root 10s. All right, let me get my eraser out. I'm going to erase this business here. And I'm going to claim what they want is the square root of that. So this is the same thing as 13 minus the root 160, but they still want the square root of it. All right? So what I'm going to make assumptions. And someone says, well, how could you make an assumption? My assumption is I can break it into 2 parts. So let me write this down. So I'm going to write down, I'm going to take this, and I'm going to make an assumption that this thing here, by the way, I realize my work looks different because some days I do things differently. I'll get the same answer, by the way. That's not an issue. So I can say maybe it's going to be root A minus root B. I'm gonna square both sides now. And what do you get? You would get 13. I'm squaring both sides, by the way. 4 root 10. And on the other side, you're going to get A plus B minus 2 root AB. We're going to equate coefficients now. So I'm going to say A plus B is 13. And I'm going to say minus 4 root 10 is equal to minus 2 root AB. All right, now here comes the tricky part. I got to look at this and see if I can figure it out. Are there A's and B that are going to do that for me? Furthermore, I bet they're going to be simple. All right. Now, before I do anything, I'm going to clean this up a little bit. Divide both sides by minus 1, and then I would divide both sides by 2. Let me do that for you real quick. All right, let me get my eraser out. I'm going to divide both sides by 2. And I'll put that down for you. All right. Now, I got to get them to look a little bit more. I'm going to say this really looks like root 40 now equals root AB. So I'm going to say 40 is what AB should be. And then what I'm going to do, I'm going to try to solve that for either A or B. I don't know. I guess I could solve it for either one. It doesn't really much matter to me. So let's say 40 over A is what B is. And then I'll take this, I'll plug it in up here. And what do you get? Well, you're going to get A, and B is what? It would be 40 divided by A, and that's 13. And I bet this is going to be easy to solve. Multiply both sides by A, you get A squared plus 40 equals 13A. A squared minus 13A plus 40 equals 0. Don't be discouraged. These things are going to work out. They're written to work. A and A. I'm using the zero product rule with the assumption that this is going to work out nicely. Looks like 8 and 5. So A could be 5, or the A could be equal to 8. All right, this gets tricky now. I say if the A is 5, the B would be 8. And if the A is 8, the B would be 5. So I got two possibilities. And so it's two possibilities for what? Well, I'm looking at the problem, and this is my problem over here. I hope you know that these are principal roots. So the root A minus root B must be positive. So it can't be this one. Because if I write this down, this is root 5 minus root 8. That would be negative. So it can't be this one. So it's got to be this one. So what's that mean? It's going to be the root of 8 minus the root of 5. So that's going to be the square root of 13 minus root 160. By the way, I do not mind the way this is written, but modern conventions say the root of 8 should be written as 2 root 2's. And that's the answer that's been provided over here. All right, next one, really kind of the same story. You're looking at it, and I'm kind of looking at it. I'm looking at the square root of something. You can make an assumption. This one I'm going to do a little differently than that's in the notes, but I'll just write this down for you. I'll just say it looks like root A plus root B. I'm nesting the roots. Square both sides. And what do you get there? A plus B plus 2 root AB. What do I know now? I know A plus B is 8. I'm equating things. I'll equate the roots now. And the root 48, whoops, sorry about that. That's crazy. The root of 48 equals 2 root AB. Well, you know what? I'm going to square both sides now. And what do you get? You get 48. That's a little different than before. And you would get 4AB now. So what's AB equal? AB would be 12. What am I going to do? Solve for either A or B. It doesn't much matter. So I'll put down 12 over A is B. And I'll plug this in up here. See what we come up with. What do you get? A plus B is 12 over A equals 8. I would multiply both sides by A. A squared plus 12 equals 8a. A squared minus 8a plus 12 equals 0. And again, making assumptions that things are going to work out pretty nicely, by the way. Let's see, what do you get there? I guess 2 and 6, right? So what's A? A could be 6, or A could be 2. Well, if we write that down, what's the B going to be? Well, it's easy because the sum has to be 8. So here the B is 2. Here the B would be 6. So that's really simple because this is an addition problem. Doesn't matter what I put down. So either root 6 plus root 2 or root 2 plus 6 would work out beautifully. All right. Again, the same thing for this guy over here. Square root of this guy over here. I'll write this one down for you. I'm going to do this a little bit differently than I did the last one. I'm actually going to simplify the radical. What I mean by the radical 32. So 22 minus 32 contains a 16. Square root of 16 is 4. 4 times 3 is 12. Now remember, I took a 16 out, so I left with a 2. And we're going to make an assumption that this is root A minus root B. All right? Let's square both sides. What do you get? Well, I'm going to write this down for you. 22 minus 12 root 2 equals A plus B minus 2 root AB. So A plus B equals 22. I'm equating coefficients. And minus 12 root 2 is equal to minus 2 root AB. And this is really the same thing we're doing over and over again, actually. So what am I going to do? I guess I divide both sides by minus 2. You would get 6 root 2 equals root AB. I think I'd square both sides. And what do you get? You get 36 times 2, which is 72, equals AB. And that make a solve for something. Then 72 over A is B. I got to write that down now, right? So this is going to go back up here, substitute, and what do you get? You get A plus, what's B? 72 over A. That equals 22. Multiply both sides by A. You get A squared plus 72 equals 22A. Let's see what I get over here. A squared minus 22A plus 72 equals 0. All right, let's take a look at that. And I got to factor that, right? It's not easy, by the way, I'll tell you that. Let me put 72 down for you. Certainly you can put 2 and 36 down, but that sounds crazy. I'm going to take 2 from the 36 and make it 18, and then give the 2 to the 2, and that would be 4. And someone says, would that work out? It sure does look like it's going to work because 4 and 18 is 22. Let's write this down. Minus 4 minus 22. So I'm going to say A is 4 and B is 22. I'm sorry, that's not true. A is 22. Sorry about that. I did it again. A is 22. What's B? Let's go back up here. And I want to point out you really have to have some understanding what you're doing over here. And I'm looking at the wrong one. I'm sorry about that. It's 22. Sorry about that. So what's the B going to be? It's going to be 18. And what's the B over here? The B would be 4. Now someone says, I can't remember what we did. And yeah, I looked at the wrong problem before. It's true. It's root A minus root B. All right. So I know my roots are positive. So it's got to be the bigger number, root A. So it's going to be root 22 minus the root of 4. So root 22 minus 2. Let's take a look at the K and see if we got that. And I think I made a mistake somewhere. Oh, you know what? I think I did. I put 22 down, and I don't know where that came from. I got to change what I was doing. I looked backwards, and I made a horrible mistake. That's going to be, I said 18, right? Remember that? So the A would be 18, and I apologize, and the B would be 4. Again, going back this thing over here, it's root A minus root B, so it's going to be root 18 minus root 4. All right? Now, again, why would I not do the other one? Because then it would be a negative number, and it's a principal root. It's not a negative number. So root 18 minus root 4, and I want to point out that's written over here. For some reason, people don't like to write root 18 down. And I understand that, by the way. It contains a 9. Square root of 9 is 3. So 3 root 2 minus 2. All right? All right, this one over here, again, kind of looking at it. Whoops, sorry about that. What I would recommend over here is to get it in the proper form before you do anything. And looking at it, the numbers, they're not outrageously bad, but I'm going to write a little bit differently, by the way. And let me take a look. I'm going to try to do a little bit differently than what's over here. And I'm going to look at let's put this down, 392. And I'm going to put 2 down, right? So 2 into 392, 150, 195, 196. Okay? And then I'm going to say 2 into 196. So it goes 2, that'll be 95, 98. And then I can say 2 into 98. 2 times 49, right? And 1 times 7 times 7. Okay? So I think I see a perfect square there. And let's put that down. So 392. I see 2 2s. And I see 2 7s. So I'm going to say that would be 14 root 2. Okay, let me keep going. Again, I'm doing a little different than we did. The reason I do that, I want to make sure you know that that you can do it differently. Now, I'm looking at the 360, by the way, and I immediately see 36 times 10, right? And the square root of that would be 6 root 10s. All right, let me get my eraser. I did something kind of crazy there. So I'm going to write a little bit differently. I'm going to write down the 392, root 392. Plus root 360. Could be written as 14 root 2s plus 6 root 10s. By the way, I still have 2 roots. I'm going to factor one of the roots out. And I'm going to factor out a root 2. And I'm going to factor out a 2. And what would you get? You would get 7 plus. I factor out a 2, right? So that'd be a 3. And I factor 2 out from the 10, that would be a 5. All right, so I'm gonna claim this over here. I probably didn't make any mistakes. That that these are all equal, and I want to take the root of it. Okay, let's do it one step at a time. And I think you're starting to see something a little bit simpler, but this is killing me. I got to get it to come out the outside, right? So I'm going to write this down for you a little different. It's really, 2 root 2s is really just the root of 8. And I'm taking the square root of the root of 8. Again, 2 root 2s is the root of 8. So that's going to be the 4th root of 8. I'll write that down for you. A half times a half is a quarter, by the way. That's the 4th root of 8. And then what you left off with? You left off with the square root of 7 plus 3 root 5s. All right, I'm doing a little different than it's in the notes, but it's really equivalent, not same problem. Let's keep going, and I'm gonna try to figure this part out now. And how would I do that? Like I've always done it. So I would make an assumption that it can be done. Square both sides. That would be A plus B plus 2 root AB. You got to keep working on this. And it's nice to have an answer key. We can always look at our answer key, but A plus B is 7, right? And 3 root 5s is equal to 2 root ABs. I'm going to square both sides of that equation with the root in it. That would be 9 times 5, which is 45. And that would be 4AB. And that would be A plus B is 7. 45 over 4A would be B. It's a more difficult one. There's no doubt about it. You got a denominator with 2 factors in it now. And let's write this down. So what do you get? A plus B equals 7. The B is 45 over 4A. I'll write that down. And again, don't be discouraged by work. I can multiply both sides by 4A. You would get 4A squared plus 45 equals, and I multiply by 4A, right? So what do you get? 4AB. You know what? I think I made a mistake there. I'm sorry. I wrote down B when it's 7. It's crazy. No excuse for that. So that would be 28. Sorry about that. And multiply by 4A, 28A. It's more difficult. There's no doubt about it. 4A squared plus, minus 28A. What do you get over here? Plus 45 equals 0. I got a factor, don't I? Let's take a look. 4 times 45 is 180. And that's 4 times 45, right? I'm using the AC rule. So we need 2 numbers that give me a product of 180. I'm sorry, I didn't mean to put A because I don't want to put that down. I need 2 numbers that multiply the 180. And the same 2 numbers have got to add up to minus 28. Well, it looks like 10 and 18 minus. All right, looks like it's going to work out pretty nice. Let's write this down. 4A squared minus 10A minus 18A plus 45 equals 0. And I'm going to factor the first 2 terms. That would be 2A. You would get 2A minus 5. Over here, what do you get? And I got to be careful. You're going to factor out a 9. You would get 2A minus 5 equals 0. Don't be discouraged. We're going to factor that now. 2A minus 5, and you get 2A minus 9 now. A, it's the most challenging problem in the set so far, right? So you get 5 halves. Don't be discouraged. And over here you get A is 9 halves. Now, sometimes I don't even remember the beginning of this problem. Well, it's a root A and a root B, and A plus B must be 7. Well, that's pretty simple, because those 2 numbers are going to work out nicely now. I mean, if this is the A, the B would be 5 halves, and if this was the A, the B would be 9/2, because when you add those two numbers together, 14/2, which is 7. So what do I get? Well, I get the root of 5/2 plus the root of 9/2. And it doesn't matter the order I put it down, by the way. Nope, it doesn't really matter. Where's that coming from? Right here. Let's not forget, though, I got this thing in front of it, which is the 4th root of 8. I got to clean that up, though. It looks terrible. Absolutely terrible. All right? So when I do that, again, I want to remind you what I'm doing over here. Let's see. I would say the 4th root of 8 and it is the 4th root of 8, right? And then I got those square roots of 2 in the bottom. And I don't like the way that looks over there. So I'm going to pull them out as the square root of 2. And you're left off with root 5 plus root 9. By the way, root 9 is not bad. I'll take care of that later. But I'm looking at that 4th root of 8 and the square root of 2. I want to write them as the same index. And 2 to the 1/2 is 2 to the 2/4, so it would be the 4th root of 4. Root 5 plus 3. Well, the 4th root of 8 divided by the 1st root of 4 is the 4th root of 2, and then you get 3 plus root 5. Are we getting that number? We certainly are, all right? Was it a lot of work? Yeah. But again, it's a skill that, I would say that you probably should look into, being able to do that. And again, someone says, well, your work is all over the place, and it's true. When I'm doing my scratch work, it's all over the place. That's what's nice about an answer key. So let me repeat what I do when I write your notes. When I write your notes, what I do is I got a bunch of chicken scratch all over the place, but then I got to neaten it up. And what I do, I type it up for you. Everything's typed up. Now, someone's going to say, oh, your typeset work over here is different than the typeset than your chicken scratch over here. You're right. Sometimes they do it one way, sometimes they do it another. But the bottom line, in the very end, that's all I'm really concerned about. Is it leading to the same answer? Of course it is. All right? The truth is the truth. All right? Exercises. What are you doing going through a bunch of these problems over here? There's a lot of problem, by the way. It's not an easy section to get through. And I know that to be true. Even when I teach now, which they give much more basic problems, students have a tough time with this. There's no doubt about it. And certainly, whether you enjoy it or not, it's got to be done. All right? Now, I'm looking at it. It's 58 problems already. This is crazy. Not really. Not that many problems. But again, you decide what's a lot of problems. I did every single problem, by the way. It isn't like I didn't do those problems. I had no help either. I did the entire book. There's 86 questions. All right? Some of these things are tough. I think you can get through it. I really do. I think get through it. All right? I'm also going to point out related Sage code. What's Sage? It's a computer algebra system, or a CAS. It's open source software, meaning it's free for you to download or use the interactive web-based application. And you could try some of this code. My real concern is this, though. Please, if you see errors in my work, email me. What I mean by that? If you're doing these problems, yeah, it's a lot of work. Let's say you're doing all these problems over here, and then you look at my answer. Let me get back to that. So let's say you're doing 45.3. Please do not give me page numbers. Page numbers change, but section numbers won't. If you give me a section number, like you say, you're in section 45.3, and you're doing problem number 37, and you disagree with my answer, and this is why you disagree with my answer, let me know that. And what I'll do is I'll read your email. I'll look at my work. I'll go to the section you told me to go to and the problem you go to. I will compare. I will try to do an analysis of what you said and what I said. We need to come in agreement, though, all right? Now, if you point out an error, I will correct my notes. In addition, I will also give you credit in the notes. Your name will appear in the notes, all right? Thank you for paying attention.